That's one of those geotubes. It's it was a big rectangular bag that was catching sand. And down right behind you all, there's a pile of sand down there, that's left over from after we took that out of there. That's that coarse sand. And then this stuff you see on the sandbar here, this is that sugar sand, okay? That's what we were not able to capture in the bag, but we're able to sample and determine how much of that was going through it. And so those two things together kind of tell us how much this little guy could collect. We were talking about impacts, in the shadow and how the collector would move. This little sandbar right here that you see just under the surface has been growing for the last 3 days because it's in the shadow of that collector, right? So there are always going to be local impacts to putting anything in the river. We just have to be able to manage them and reduce as much as possible those impacts. The orange floats are on there, one, because that's where the chains are that we need to get the excavator to snag it out of there, and two, they're there as a safety marker. If we had a couple of kayakers go by this morning, and for safety, we want something out there that they can at least see and avoid, and you do the same type of thing on a permanent installation. So what we've been doing, so Chuck's gonna put a bag on here, or a sock as we call it, and this is our real high-tech sampling system. All right, it's a filter essentially, and it's got very similar, porosity to the geotube. For those of you who've worked in ag drainage tile, it's simply that filter sock that you put over the black ABS drainage tile before you put it in the ground in a farm field. So we just get a big roll of that and tie it off and use it as the sample bags, because it does a great job of capturing that, let's call it that playground sand size material.
Okay.
Gonna give it a rip?
You man the hose, I'll turn the pump on.
All right, so you can watch this here. Hopefully it covers you all in water. And you can feel like we have for the rest of the day, or for the rest of the week. But so essentially it's been sitting for, say, 15, 20 minutes. And it's not, we're not gonna get a yard of sand out of it, but you'll see that, there is some of that coarser material that has been, collected in it. But you can see, like, the water's brown coming out of it, right? That is that fine sand. That's that sugar sand that's going through the sock. So your silts and your very fine sands are coming out, and we take samples of that, and we know how fast, what the flow rate is of the pump, and so we can figure out how many tons of that fine sand we collect in an hour versus how many tons of this coarser sand we would have, and so there's already, that's that playground sand that's being collected in there that fell into the collector during the maybe 15 minutes. But we were talking about that like playground sand, right? So that's what this is that we're catching here, and we're catching all of this load. So that's kind of a medium sand. This is like somewhere between 0.2 and 0.5 millimeter. Pretty common medium sand. Yeah, and then this is, you see it under your feet. That's that very fine sand. It's powdery and it blows away in the... So we take what we measure in here, we'll run one of these bags for 15 minutes and we'll weigh the bag, what kind of this sand, so we capture that, and then we'll take a water sample. We know how many gallons we ran through in that same 15 minutes. We'll do analysis on that for concentration and total mass. So we can add the two together and say, this little collector it collected X number of tons per day. And then we can, do that thought exercise about what does scaling up look like as part of the analysis on the backside. So, any questions? It's small. We understand that. It's a couple yards. Because a couple yards is all we need for the science part of it to understand how it would perform. We can do it on kind of this small scale because it is scalable, right? We could put it all the way across this channel, all the way to that sandbar over there if we wanted to, and collect 5 times as much sand. So that's kind of how we'll write it up. And as Scott said, this is one of the 4 technologies we'll be looking at as part of the phase 3 of the sediment management plan. On the back side of that is some recommendations in a Corps of Engineers document about effective methods with some general economics about actions we know would be successful and actions we can take to reduce the impacts of the sedimentation here. We have to be very honest with ourselves. We're not going to eliminate the impacts of the sedimentation. That problem is, it's been building for 70 years, right? And so if we have 5 million yards a year, 70 years, 350 million yards, a third of a billion yards of sediment in this system. We're not going back to 1960. That's just, that's literally $1 trillion project. But what we have is the opportunity to, from this point forward, start to mitigate extend what the next 60, 70, 80 years looks like. And there very well may be, additional decades of life that we can tag on to the Gavins Point project, while at the same time kind of slow the rate at which some of this deposition is happening above the reservoir. So, any other questions?
Do you have any issues with these things floating up?
Yeah, you can. Yeah,
I assume it's time of year based. Probably.
Yeah, so one of the reasons we're here, right, and we talked a little earlier, is unlimited sand supply, and we're in a spring-fed river. There are very, very few rivers of this size in the upper Midwest that are flowing like this in September and October and December. And you come out here in January, the base flow, right, is still, we're at about 1,800 cubic feet per second right now. Base flow in the winter is still 1,000 to 1,100 cubic feet per second. So if you're looking for a place with continuous chronic sediment, but the flow to keep it moving, this is the perfect test bed for this type of study. So, but yeah, because we knew it was going to transport a lot of sediment, we have been running it constantly so it doesn't bury itself.
I mean, you've got screens on there, right? That filter.
Well, I mean, there are screens.
Leave, detritus, things like that.
So the screens have a gap of well over 1/2 inch. They're actually bars. They're about, fire up your grill. Okay, they're about like that spacing. They're about 1/2 inch apart. So, we do occasionally snag some tree trash or something, but it doesn't suck down hard enough to like pin woody debris or anything like that. And we'll suck it through here, and I'll get in these bags. There's a little woody trash that comes through the pump. There's leaves, stuff like that. But the grates are large enough that that's not gonna plug things. And it doesn't, relative to the amount of water we pull out relative to the screen opening, means that, the rate at which that water is moving through the grates is very, very slow. It's much slower than the velocity of the water just going by in the river. There's just a very slight downward trajectory of that sediment to go into the grate. It's not, it's not sucking it like a sump pump would, and hard down there. So most of that stuff just goes right over the top. Another question over here?
I was just going to say the coarse sand represents what, about 1/3 of the sediment?
We're guessing, we haven't done the numbers yet, but kind of just looking at a visual observation, I'm guessing probably 1/3 of my total mass is this sand, and the 2/3 of it is probably this finer stuff. This is the easier stuff to catch, right? But it's also the smallest fraction of what we're working with. So if we can take a bunch of this, which is easy, but if you're going to talk about, incrementally increasing your collection and starting to get larger volumes, you're going to have to address the finer fraction of this as part of that. And honestly, that finer stuff is more valuable than this. This is that bag of general sand for $2 a bag at the home improvement store. That fine stuff is what you find in those Portland cement mixes, and you make glass out of, and you use as slurry mixes and all of that. So, that's one thing we've talked about with Scott and MSAC, is we kind of do in evaluation. Now that we know kind of what the split is of these different sediments, we need to ask ourselves, are there different economic opportunities for the different kinds of sediments? And is one more valuable than the other? And so should we focus on one or the other of those when we're looking for economic opportunities?
I know like Core does the Waters of the U.S. and all that stuff.
Yep.
They don't make a lot of friends usually. That type of stuff.
Oh no, we're...
Can't you give it back to the people that let it dump in? Not that it's their problem, but you know, get rid of the sediment, put it back. Every landowner along the Missouri or along the Niobrara has to take 2 tons a year. That type of thing.
So there's a combination of sources here, but and you're right, there is some of it that comes off runoff. There's always improvements to be made in land management and grazing and agriculture and all of that. But one of the biggest drivers of this sediment transport is that it is a fully sand bed, and we have a spring-fed river. So the majority of the material is not coming from the banks. Still a huge concern, still a big driver in it. But the biggest contributor is directly from the bed of the river, which in theory nobody owns, right? So who do you give it back to, kind of thing. So everybody, absolutely. I mean, yeah, and we talked earlier about this, right? Almost all the supply comes from, you know, above say Spencer Dam reach, and then another big chunk of it is, say, from, you know, Valentine West. So this reach here is not a contributing reach. This reach, say this last 30, 40 miles, you're not adding any sediment to the budget down here. This is a receiving water, right? So it's taking what's coming from upstream, and because you've got the backwater right here, we're in a depositional reach. We talked about this with a school class earlier. We dug up the surveys going all the way back to 1955. Where you're standing right now was about 15 feet lower in 1955. So this whole area here, about the bottom 5 or 6 miles of the Niobrara, has come up anywhere from 15 plus feet at the mouth to 5 or 6 feet up at the turn by Verdigris Creek. We monitor all the way up to 15 miles above the mouth, and we see aggradation, which has raised the bed over time all the way up to about 13 miles currently. And that will continue. As this lower reach raises, you'll continue to get more and more backup higher up in the river.
You touched a little bit on this sediment's collecting here. It needs to be below Gavins Point Dam. Is there any discussion on how to make that happen down the road at some point?
You know, we understand pretty well, you know, the physics of these different processes for moving it. Putting it back in the river then becomes more of a discussion between the state and local partners, between kind of the upstream and downstream 12 or 14 downstream states that are associated with the Missouri Basin and subsequently the Mississippi River Basin. So that is a you know, a discussion that needs to and will start happening more and more, especially as we identify in the sediment management plans what some of these actions are and the volumes that they may be able to, you know, move. I think it's going to become more and more, you know, obvious that has to be a part of the equation. You know, Nebraska, we were talking about this last night with some folks. Nebraska's in an interesting situation because they are one of the very few states that has a reservoir impacted reach of the river and a kind of natural stretch of the river down to Ponca, and then they've got a navigation channel for the rest of the, you know, the eastern border. So, you know, Iowa's only got the navigation channel. South Dakota is generally the reservoir reaches and that kind of thing, but Nebraska's got all three. So you've got a lot of competing interests and a lot of competing, you know, benefits to try and balance with any sort of management plan. Because I can find plenty of folks that, you know, run a duck hunting outfitter, and they would really prefer that, you know, we don't open up the lake because there is an economic benefit that and that delta and the environmental conditions have been adapted to by a commercial enterprise. Downstream stakeholders may be worried about sediment depositing there, increasing flood risk, changing water quality. There's all of those concerns are there too. What would it do to the navigation channel? How would we mitigate that so as to not cause shoaling of that? And that's a decades-long discussion, because you're not magically going to start putting sand in the river and it's going to show up in New Orleans, right? You have to get to a point where you've got enough sand to start moving, and then that, these trends in degradation have taken decades to develop, and they will take decades to somewhat mitigate too. All right, any other questions? All right, well, you get a show here too. You get to see this thing come out of the water. This is what, if you're a summer hire for the Corps of Engineers, you get to go wading and do this. No, so I'll take this opportunity. All these guys are from the Gavins Point project office, okay? So we've got outside maintenance, we've got plumbing team, we've got electrical team, we've got heavy machinery team, all of that. This project does not happen without them, right? With the tight budget we're working on, we don't have the resources to go out and hire a bunch of contractors to do this privately. So we've had to rely, and I feel bad anymore. They've never said no. I keep asking for things over and over. I'm like, hey, can you bring out the skid steer? Sure, we'll bring out the skid steer. So they have been absolutely amazing, and that like I said, it doesn't happen right here without them.
What do you suppose the cost of this would have been with private commercial contractors?
Well, if we also add this equipment, you're a couple, I would guess $10,000-$20,000 to get, this machinery on site for a week with operators and then the contracting costs that it would take to award something, and a staff here. So yeah, this is another piece of the Corps putting in, because this is all in operations and maintenance. We have different flavors of money in the federal government.